Hey folks, got a quick example involving impulse and a graph. So we have a graph of force versus time. So for instance, this might be a first approximation for the force of like you hitting a tennis ball. So if you look at a tennis ball as it's being hit, when the tennis ball first touches the racket, the force will be very tiny. But then as you're swinging through the ball, when the ball gets really crushed like this, okay, then the ball is feeling a lot of force, and you can see it's been crushed some, and the tennis racket is uh, is the strings are compressed some. Okay, um, and then as the ball is released from the racket, the force will go back down. Okay, so this is a first approximation of what that force might look like. I'm sure it's more complicated than this, but it's a good start. So let's say a ball is coming toward you, and I don't know what kind of ball it is, but let's say it's got a momentum of 2 kilogram meters per second. So that's the momentum of the ball before it strikes you. And let's say you hit the ball and the force that you hit it with is this graph. Okay. And let's say I tell you the mass of the ball is 1 kilogram. So it's no longer a tennis ball. It's something significantly larger, like I don't know, heavy basketball or something like that, or maybe a book. And you strike it with this force. And let's say that you find the area of this graph and it's 5. Okay. What would the area be unit wise? Well, you're taking newtons times seconds. Well, that's impulse. Okay, so it turns out if you have a force time graph, area is impulse. Okay, so if I strike the ball with this much force over that much time, such that the area is 5 Newton seconds, what's the final momentum of the ball? Okay, well, we'd assume that the ball's coming towards you and that you're hitting it the other way. Okay, so I'm going to make to the right positive. So the starting momentum is +2. And so this is actually, we're going to say it's a negative impulse. You are hitting the ball to the left. Okay. Well, impulse is change in momentum. Okay. So that impulse is -5. It's to the left. Now, most of you can work this out. If the starting momentum is 2 and it changes by -5, and the final has to be -3. But if you had more complicated numbers, something like that, you could just do this. Delta is just P final minus P initial. All right. And the initial was 2. So if you add 2 to both sides, you get P final is -3 kilograms meters per second. And then if I asked you for the velocity of the ball, we know that momentum is just equal to mv. Now, if we have a mass of 1, then the velocity would be -3 meters per second. But whatever mass you'd have, you just divide by that, and that would give you the velocity of the ball at that moment. All right, so that was a quick example. Hope that was helpful, and thank you very much.